Interdependency evaluation is the process of analyzing and assessing the relationships and dependencies between different components in an industrial control system. In critical infrastructure, sectors such as energy, transportation, telecommunications, and water are increasingly interconnected. These complex systems are comprised of many interdependent components, such as hardware, software, people, and processes, as well as internal and external dependencies. The components involved are often designed and operated independently, but do need to work together in order to support critical functions. This interdependency creates a complex web of relationships and dependencies that can lead to unexpected failures and cascading effects if not properly managed. Even within your own organization, different disciplines manage their own components of a complex interconnected system. Safety, chemical, mechanical, and automation engineers may all have different perspectives, but it is only through combining those unique viewpoints that we can gain a holistic understanding of the dependencies within ICS, as well as the downstream consequences of failure. Interdependency evaluation aims to identify and understand relationships and dependencies between different components. This includes analyzing how failures or disruptions in one component can affect the operation of others, and how these effects can propagate throughout the system. To imagine this idea in practice, a power outage in a city would not only impact the availability of electricity to the citizens and buildings within it, but would also disrupt the operation and availability of transportation systems, communication networks, and other critical infrastructure services that rely on that electricity. Understanding these interdependencies is critical for designing resilient and robust critical infrastructures. By identifying potential vulnerabilities and risks, engineers and operators can take proactive measures to mitigate or eliminate them. This may involve implementing redundancies, backup systems, or failover mechanisms to ensure that the system can continue to function even if one or more components fail. Additionally, developing manual safeguards, contingency plans, and emergency response procedures can minimize the impact of disruptions when they ultimately do occur. Interdependency evaluation is also important for ensuring that critical infrastructure systems can adapt to changing conditions and requirements. As society and technology evolve, so too do the demands placed on critical infrastructure. Even today, we see the increasing use of renewable energy sources that may require changes to the design and operation of power grids to ensure that they can accommodate variable generation and load. Similarly, the increasing reliance on digital technologies may require changes to the design and operation of communication networks to ensure that they can handle the growing volume of data traffic. By including all relevant stakeholders in the engineering design process, we can address these critical dependencies before they become an issue. Interdependency evaluation allows organizations to assess every angle of risk from the different disciplines involved in order to mitigate vulnerabilities and maximize security. Contact us today to learn more about cyber-informed engineering and see how OpsRite is helping other critical infrastructure organizations secure their plan using the OpsRite Impact platform to deliver secure engineering by design.